As most probably know, the video game Fortnite Battle Royale has grown into a global sensation. Its unique style and features combine for a wonderful new experience. The Fortnite world is a rather large island located in an unknown area. The developers do nothing to elucidate the location of the Battle Royale arena. As a result, no one knows where on Earth the game takes place or if the game even takes place on Earth. Furthermore, does the world in the game have constant physical laws? Did the developers sacrifice logic in order to create the most fun product? There's only one way to find out.
First, we had to establish some sort of unit system to be able to measure distance. In order to relate to our physical world, this unit system must somehow relate to the real-world units such as meters or inches. Additionally, we must be able to somehow use this measurement system to get precise numbers between any 2 points. These parameters for a measurement system made it quite difficult for us to find one. So the first thing Garrett and I ended up having to do is try and get into a game together. And the way we did this was we went on the Fortnite mobile and went in the Oceanic servers so that we could just have a game where we'd be in the same world.
Once Charlie and I were in the same game, the most important thing was finding a sniper, because the sniper is the only gun in the game that will tell you the distance of the kill. So once Charlie and I were in the same game and we had a sniper, what we did was we laid out a series of wood platforms. We then counted how many platforms there were and had one person stand at either end of the platforms. We then had the person with the sniper shoot our other person, and the game told us the distance in the bottom left of the screen. So then we had a distance and how many blocks it took to get that distance for the snipe.
After each of the trials sniping each other, we divided the total distance of the snipe that showed in the bottom left of the screen by the amount of platforms we had between us for the snipe to get the total amount of distance for each platform. The first time we did this, we were 27 platforms apart, and the kill said 138 meters, which when you divide 138 by 27, you get 5.1 meters. The second one, we were 20 platforms apart, and the snipe said 103 meters, which we divided and got 5.1 meters again. And then the third, we were 15 platforms apart, and the kill said 77 meters, and we got 5.1 meters again. We assumed that we had some sort of issue where the game registered the distance from the bottom of the feet rather than the barrel of the gun, which would mean that each of the platforms, each of our distance were like 2 or 3 meters larger than they should have been, which if we factor this in, then every single platform would be 5 meters exactly, which would make more sense given the context of the game and the intent of the designers.
And right here we'll show how we set the experiment up. Because Charlie and I were not able to screen record, we had to set the experiment up on console, where it was practically impossible to get into the same game together. So here I set the experiment up by myself, and I didn't have an enemy to shoot at, but you can see I laid out the platforms, turned around and scoped in on the ends, and if I would have had an enemy, a distance would have appeared in the bottom left corner.
Now, after establishing a measurement system, Garrett and I are able to actually get into some real testing and measurements to determine the physics of the Fortnite world. The first thing that Garrett and I wanted to examine after determining a measurement system was how quickly, or the acceleration at which the players fall due to the gravity in the game. The way we decided to go about this was by building up towers and dropping off them in time. We did 3 separate trials. The first was we built up 5 blocks, the second we built up 10 blocks, and the third we built up 15 blocks. After doing this, we will get both a time measurement and a delta x, or distance measurement, which is all we need to determine the acceleration. We'll use the equation delta x equals v naught t plus 1/2 at squared. We know that the initial velocity, or v naught, is equal to 0 meters per second, and then we'll find the time and the distance by each of the trial. After this, it will simplify to be 2 times delta x over t squared will equal the acceleration. Right here, we begin demonstrating the setup of how we did this experiment. As you can see, we're building with the wood in-game, stairs up, which each are also equal to 1 platform, but we show behind it a wall, which also demonstrates the exact height. We build up to the certain height we stated, either 5, 10, or 15 blocks for which respective trial, and then walk right off the edge so that there's no initial velocity, and then you can see the trial as we did it. Here's some footage of our first trial we did. This is obviously, as you can see, the 5-block trial. After walking up to the top and then dropping off the edge, we timed it 5 different times and took the average and found that it was 1.33 seconds to drop. The 5 blocks is equal to 25 meters. And then after doing the calculation, 2 times 5 times 5 divided by 1.33 squared is equal to 28.27 meters per second squared. That's obviously a much higher gravitational force than the one we have on Earth. Interestingly enough, when we took our second trial, we found that there was an inconsistency we weren't actually expecting. Here you can see we have built up 10 blocks, which is equal to 50 meters. Up at the top, you can see right now we are about to drop off the edge. And when we drop off, it's equivalent to exactly 1.54 seconds, sorry. Doing the calculation, 2 times 50 divided by 1.54 squared, we get 42.17 meters per second squared. Our acceleration due to gravity has changed between the two trials. This was obviously a shocking result we weren't expecting, and especially shocking because if we were being logical, the gravitational force should only decrease as distance increases. However, this obviously almost doubled. So we found an inconsistency we weren't expecting. Obviously, at this point, you can already conclude that the Fortnite world doesn't obey physics of the real world. However, it doesn't even seem to obey the physics that's set up in its own world. There's already some radical inconsistencies, and we only will find more as the video goes on. Here you can see Garrett and I have begun our third trial. On this trial, we built up 15 blocks. 15 blocks times 5 is equal to 75 meters. Overall, we ended up falling on this trial in a total of 1.76 seconds. So 2 times the displacement of 75 meters divided by the time squared of 1.76 seconds ends up getting an acceleration due to gravity of 48.42 meters per second squared. Again, the gravity increased as the distance increased. This is another inconsistency, and it doesn't make sense given the context of the Fortnite world. Next, Garrett and I will explore if the dropping of guns has the same physics as they fall to the ground as the humans do, because at least that would establish some sort of consistency.
For the gun drop trials, we repeated the same procedures for building a 5-platform tall tower, which is 25 meters, and then we recorded the time it took for the gun to fall to the ground. For the 5-platform tall, it was 3.8 seconds, and then once you plug this number into the equation, the acceleration due to gravity was 3.46 meters per second squared. For the 10-platform tall tower, the average of the 5 times was 8.38 seconds, resulting in an acceleration due to gravity of 1.42 meters per second squared. And here is the third and final trial, the 15-platform tall tower, where the average time for the gun to fall was 11.32 seconds. When plugged into the equation, it resulted in an acceleration of 1.17 meters per second squared. Now, these results were really shocking because they provided even more inconsistency for the game. As you can see, in all 3 of the gun drop trials, the acceleration due to gravity was much smaller than it was for the human, which of course should not be true because according to the law of gravity, all things should fall at the same rate. What was also surprising was that the gun had an inverse relationship compared to how the human fell. As the platforms got taller, the guns actually had a smaller acceleration on the way to the ground. Now, what's been showing up on your screen for a while are our calculations for all the human trials and the gun drop trials. You can see the acceleration that resulted in each trial, the 5-block trial, the 10-block trial, and the 15-block trial, as well as the height that the gun or person fell, as well as the average time that it took the person to fall that distance. Thank you so much for watching our video, and we hope you enjoyed it.